Hello everyone, my name is Rutuja Taide and today I will be presenting my topic Training and Prediction of Generative Adversarial Network along with a brief overview of GAN loss functions. GANs are an important concept in deep learning and artificial intelligence, especially in tasks like image generation, face creation and data synthesis. In this presentation, we will understand what GANs are, how they work, how they are trained, and how loss functions help improve their performance. So let's start with the introduction of GANs. GAN stands for Generative Adversarial Network, which is a powerful deep learning model used to generate new data that is similar to the training data. This model was introduced by Len Goodfellow in the year 2014. GANs are widely used in artificial intelligence for generating realistic images, videos, and other types of data. A GAN consists of two neural networks called the generator and the discriminator. These two networks work together in a competitive way to improve the quality of generated data. So, what are the components of GAN? A GAN mainly contains two important components, the generator and the discriminator. The generator is responsible for creating new data from random noise. Its goal is to generate data that looks similar to real data. On the other hand, the discriminator acts like a classifier. It checks whether the input data is real or fake. In simple terms, the generator tries to fool the discriminator while the discriminator tries to correctly identify real and fake data. Because of this competition, both networks gradually improve. Working of GAN. Now let's understand how a GAN actually works. First, the generator creates fake data using random noise as an input. Next, this generated data is sent to the discriminator along with real data from the dataset. The discriminator then tries to determine whether the input data is real or fake. If the discriminator successfully detects fake data, the generator learns from this and improves its generation process. This process continues repeatedly until the generated data becomes very realistic. Training of GANs. Training a GAN involves training both the generator and the discriminator simultaneously. First, the discriminator is trained using both real data and fake data. After that, the weights of the discriminator are updated. Next, the generator is trained to produce data that can fool the discriminator. Then the generator's weights are updated. This cycle continues many times during training, allowing both networks to gradually improve their performance. Adversarial training concept. So, the process of GANs is called adversarial training. In this process, the generator and discriminator compete against each other. The generator tries to produce realistic data while the discriminator tries to detect fake data. Because of this competition, both models improve over time. This adversarial learning process is the key reason why GANs can generate very realistic outputs. Prediction in GANs. After the training process is completed, the generator becomes capable of generating new data samples. This process is known as prediction of generation in GANs. The generated data often looks very similar to the original dataset. For example, a GANs can generate realistic human faces, artwork, or synthetic images. They can also be used for data augmentation, which helps improve machine learning models by creating additional training data. So, what are the applications of GANs? GANs are widely used in many real world applications. One of the most common applications is image generation, where GANs create realistic images. They are also used in video generation and deepfake technology. In medical images, GANs help enhance image quality and assist doctors in diagnosis. Another important application is super resolution, where low quality images are improved to high resolution. GAN loss function. In machine learning models, a loss function is used to measure how well the model is performing. In GANs, there are two main types of loss functions: generator loss and discriminator loss. The generator tries to minimize its loss by producing realistic data. At the same time, the discriminator tries to maximize its accuracy by correctly identifying real and fake data. These loss functions guide both networks during the training process. Discriminator loss. The discriminator loss measures how accurately the discriminator can classify data as real or fake. If the input data is real, the discriminator should output the value as 1. If the data is fake, output should be 0. The loss increases when the discriminator makes mistakes, such as classifying fake images as real or real images as fake. By minimizing this loss, the discriminator becomes better at detecting fake data. So, what is generator loss? The generator loss measures how successful the generator is at fooling the discriminator. If the discriminator easily detects fake images, the generator loss will be high. However, if the generated images look realistic and the discriminator cannot distinguish between them from the real images, the generated loss is become lower. The ultimate goal of the generator is to create data that the discriminator believes is real. So in conclusion, generative adversarial networks are powerful generative models used in deep learning. They consist of two neural networks, the generator and the discriminator, which compete with each other during training. The adversarial training process allows GANs to generate highly realistic data. Loss functions play a crucial role in guiding both networks to improve their performance. Because of their powerful capabilities, GANs are widely used in artificial intelligence applications such as image generation and data synthesis. Thank you for watching this presentation.